Good morning, everyone. As we have discussed what is DFA in Finite Automata, and now we are going to see what is NFA in Finite Automata. Okay. So what is NFA? It is nothing but more than one destination from one state to another state. At least one state has its own transition that cannot be completely determined by the input and its current state. If it is possible to design a machine where a single input can have two paths to an accepting state, it is also possible null transitions. It moves on null transition on epsilon. It can move from a state without any input. We can see one example. So this is also a mathematical model of set of all these states. Here Q is nothing but finite state of state. Sigma is nothing but input alphabet. Here delta is nothing but the number of states. S is nothing but one in start state and F is nothing but one final state here. So here the range of delta is not a single element. It can be a any number of element, that is subset of Q is Q1 on A. It can reaches maybe on Q2 or it is Q0. On A, either it reaches the Q0 or Q2. So empty string also, that is null input, can result in a change of state. On empty, that is on empty state symbol, it can reaches any other states. So see the difference here. For each DFA, we have only one input symbol to transition from one state to another. But here in NFA, we can have more than one input symbol on reaching from one state to another state. Okay, see here from QI on A, it is reaching either QJ or it is QK. So this is nothing but NFA. On empty symbol also, that is on null transition also, it can reach us from one transition to another without having any input symbol. So we have here stuck state also. It is no jumps out of state labeled with the input state. It cannot be, that is nothing but it cannot be lead to accepting state, or it removes need for a trap state. Input is accepted if only any resultant configurations lead to an accepting state. So consider this given an NFA for a string. W implies epsilon delta star, which is W is accepted by A if at least one of the configurations or Q0 comma W, it is a configuration in the form of F comma epsilon. We'll see one examples here. So see, starting from Q0 state, on A it is moving final states. Okay, on A it can reach as the final state, or else it is reaching the on B, it is reaching another state. This is DFA here. So same thing we can consider on one state A comma B. On A comma B, it can reach as the Q1 state, or from Q1 on A comma B, it can reach as the Q2 state. So as a DFA, it is reaching only on one input symbol, but here you can see the on epsilon, that is using null transitions, it is directly going to the final state. If there is no any input symbol, then it can directly reach as final state on epsilon symbol. So this is the main difference between the DFA and NFA here. So we have already seen what is DFA, right? So this is nothing but only one state is moving on one state. It is moving from one state to on one input symbol. It is moving from QI to QJ. But here it is on the different on the same input symbol. It is moving from QI to QJ here. So this is all about NFA in finite automata. Thank you for listening.